So we are starting real numbers. This is in continuation with class 9th. We studied in class 9 real numbers, but we studied about their basics, like real numbers are divided into two parts: rational numbers, irrational numbers. Rational numbers are those numbers which can be written in the form of p upon q, where q is not equal to 0. P and q are integers, and this is which cannot be written in the form. And irrational numbers are in terms of decimal, non-terminating, non-recurring decimals. Non-terminating and non-repeating decimals. Okay, non-repeating. And here it may be terminating decimal or non-terminating repeating. So when two times non will come, it will become irrational number. Non-terminating, non-repeating, that we have studied. So now we will go ahead for real numbers. These more things we have to study here. Before that, you should know the two things about algorithm. What is an algorithm and what is a lemma? What is the difference between algorithm and lemma? So algorithm is the series. It is a series of well-defined steps which gives a procedure for solving mathematical problems. So it is the steps to solve the problems. Well-defined. You can say well-defined steps. Well-defined steps to solve a problem. Okay. So algorithm you must be knowing. Lemma is a proven statement. No need to prove that. Lemma is a proven statement used for providing another statement. It is a proven statement. So if the theorem is given, we are going to prove. But lemma, we are using the proven statement for proving another statement. One statement used for proving other things, or other questions used for proving another statements. That is the basic difference between algorithm and lemma. Then we have Euclid's. Now our first topic is Euclid's division lemma. Today we will start that Euclid's division lemma. Euclid's division lemma. It is a proven statement, and this statement is very simple. You must be knowing. I will explain you first. Suppose if you are dividing 5 by 3, we have to divide 5 by 3. So what we will do? 5, 3 ones are 3, 3 to the 6. So 3 ones are 3, 2 is left. Okay. So here 1 is called quotient, and this 2 is called remainder, and this is called divisor. Because it is dividing, it is called divisor, and this is called dividend. It's called dividend. Okay. The dividend, divisor, quotient, remainder. Okay. So here 5 can be written as, we can write 5 as 3 divisor, dividend is equal to divisor into quotient plus remainder. 3 1 3 plus 2 5. So 5 is what? 5 is a dividend. So this is a division lemma, that dividend is equal to always equal to divisor Dividend is equal to divisor into quotient plus remainder. Actually, this is a equivalence division lemma. So here we are just first we will take, actually in our course we have for given positive integers. So equivalence lemma, the statement for equivalence lemma is for given positive integers a and b. That means we are taking any two positive integers a and b. A and b. A and b are two given any two positive integers. If so, then there exists then there exists unique integers. There exist unique integers q and r. There exist unique integers q and r such that, or satisfying the condition, a is equal to dividend is equal to divisor into quotient plus remainder. A is equal to dq plus r. This is a actually, and divisor is denoted by b, and here quotient is denoted by small q and remainder is denoted by small r. Where it is very important, where r is greater than equal to 0 and less than b. Always r is less than b. What is b? B is 3. Therefore, here 2 is less than 3. So always r is less than b. Here r is 2. So 2 is less than 3. So r can be from 0 to less than 3. So any two integers, if you see any two integers, so we can write like this. Okay. Where r varies from 0 to b. That means 0, 1, 2, 3. For example, here if I will see 2, here it is r is equal to 2. So r can be 0 and 1 also. 5 can be written as, if you will take r 1. So here 4 will come. 4 ones are 4 plus 1. It will become 5. Okay. So we can write by this way. And if you take r is equal to 0, we can write 5 is equal to 5 into 1 plus 0. So here you can see the first condition here. Here r is equal to 1. Here r is equal to 0. And here r is equal to 2. Okay. So it's very important. So now that means we can write in three ways. Any two numbers if we take, we can write r from 0 to less than b. This is the statement. Here also you can extend. Here you can also write as, here a is equal to that q already. We did already that. A is what? A is dividend. B is divisor. B is divisor. And q is quotient. Q is quotient. And r is remainder. R is remainder. Okay. An example I told you. This is the example of this one. So in the notes you will write first. This is your first day. So you will start making your notebook, because maybe after holidays or school will start. So that time you have to submit, or online maybe I'll ask. So you should start making your notes. So Euclid's division lemma and its example. But this is what we have seen, that this is for positive integers. We state this Euclid division lemma for positive integers, but it can be extended for all integers. It is not necessary that it is for positive integer, but in our course we are taking only positive integers, so it can be negative integer, any integers, it can be any integers. So it is means you must know that it is true for all integers. Means it follows all the integers. We take negative also, it is followed, but except 0, except b is equal to 0. If b is 0, therefore then it will become infinity, because if a upon b, we are dividing, divisor is b, so a is divided by b. So if b is equal to 0, it will become infinity. This is the way of writing infinity now. Okay, so a upon b, that's why except b, otherwise it is true for all. So that can be asked in objective type question, because you should know that it is not for only positive integers, but in our course we are studying for positive integers only. Okay, and you can see here one more thing, very important thing, that we are going to apply the division lemma to find the HCF of two numbers, two positive numbers. So if you see here, 5 can be written 5 into 1 plus 0, 4 into 1 plus 1, and 3 into 1 plus 2. Okay, so this you are getting the value of r. When r means we cannot maximum value, at maximum value of r, you will get the value of here quotient and divisor and quotient. So this divisor 3 and quotient, divisor and quotient. So here you will find this number quotient, means this quotient will be the HCF of these two numbers. This will be the HCF of. So what is the application of this Euclid's division lemma? We will use to find the HCF of two given positive numbers. We'll find the HCF of two given positive numbers, and I will show you that the steps how we will find that. I'm going to write the steps, then we will do the question. Your first exercise, first question is based, find the HCF by using Euclid's division algorithm. This is a lemma. When we are applying, when this lemma will be used to find the HCF in stepwise procedure, it becomes algorithm. So don't get confused. It is in question, you will find that use Euclid's division algorithm to find the HCF of two numbers. So there are some steps that we have to follow to find the HCF of two numbers. So that steps are called Euclid's division lemma. So now I am going to show you what is Euclid's division lemma. If in the question, in the examination, if they are going to ask, write Euclid's, so how we will write Euclid's division algorithm. Second part is Euclid's division algorithm. So after this class, we will take 10 minutes break. So write down fast so you can take the snapshot also. Let two, we will be given first two integers. So let two integers A and B such that such that A is greater than B. First, we will see which one is greater. We will take the greater one A, and then second step, take greater number, means take A as dividend and B as divisor. Obviously, we will take greater number as dividend and then apply the Euclid's division lemma. Now find whole number numbers Q and R as quotient and remainder and remainder respectively by using the Euclid's division lemma as A is equal to BQ plus R, where R is greater than 0, greater than equal to 0 and less than equal to B. And if R will be 0, whenever you will get R is equal to 0, you will start doing it, and if R is equal to 0, B will be the HCF. B is the HCF. And if R is not 0, if R is not equal to 0, repeat the above procedure. Repeat above steps till you get R is equal to 0. So we will divide to get the value of R 0. At last, when the value will become R 0, then our value of B will be the HCF of these two numbers. Okay, so here the next part